Here is another example similar to the previous one. So we'll use the same method. First thing is just identifying the important things. The step size is 0.25. The initial conditions that you're given, x0 is equal to 0, y sub 0 is equal to 1. So those are our initial conditions. You know where to put them. X sub 0 goes there, y sub 0 goes there. And the formula is in the formula booklet. Y sub n plus 1 is equals to y sub n plus h multiplied by f. And this is actually the gradient. So you just plug your known values of x and y to find the gradient. So this is m. You plug these values in the differential equation to find what m is. So this is equal to m. All right. So should have used a different color for this. So this is m. All right. So we are going to start here. So for the initial values that you're given, the gradient will be equal to, we're just going to plug these values in the original function here, right? The original differential equation that you are given. So if you plug those in the differential equation, you'll have 0 plus 1 over 0 plus 2, which is equals to a half, which happens to be 0.5. Okay, now I'm just going to go to the step size here. The step size is 0.25, so this will be 0.25. Just add 0.25, 0.5, 0.75, and 1. So we are stopping at 1 because we want to find the value of y when x is equals to 1. Okay? Now, so the next step here is you take the previous value of y, which was 1, plus 0.25 multiplied by the previous gradient, which is 0.5. Oops, this is 0.5. And that will be equal to 1.125. Okay, so that will be 1.125. And then you carry on. To find the gradient, you just plug this back to the differential equation above, this one. So to find the gradient, that will be equal to 0.25 plus 1 over 0.25 multiplied by yes, your x and y values multiplied by 1.125 plus 2. All right. So you just plug them back into the whatever differential equation with the corresponding values of x and y. And we end up with 0.5479. All right. So here, previous y value 1.125 plus the step size 0.25 multiplied by the previous gradient 0.5479, which gives us 1.26199. All right. So, and then you plug this into the original differential equation. So you're going to end up to get the gradient for these corresponding values of x and y. So that will be 0.5 plus 1 over 0.5 multiplied by 1.26199. All this plus 2, which will be equal to 0.57013. Okay. And then what you're going to do next is take the previous value of y, which is 1.26199 plus 0.25 multiplied by the previous gradient, which is 0.57013. And what you end up with is 1.4045. Okay? And use the current values of x and y, plug into the original differential equation. So you have 0.75 plus 1 over 0.75 multiplied by 1.4045 plus 2. And this will give you 0.5731. Okay, and then the last step, you now use the previous y value, which is 1.4045 plus 0.25 multiplied by the previous gradient, which is 0.5731. And what you end up with is your y value at x is equals to 1, which is 1.5478.